Welcome to the Jack Westin MCAT Podcast with your hosts, Michael Maleka
and Molly Kilty. Hello, everyone, and welcome back to another episode of our Jack Westin MCAT Podcast with your hosts, Mike and Molly. So in our last episode, we were really wrapping up this little mini unit we had on, the reproductive system, gametogenesis, fertilization, and then kind of the growth of that early zygote. And starting now in this episode, we kind of get into one of the most important organs that just grows, develops, and appears, and then, really reigns over our entire life, the brain.
We love that thing. Woo!
The brain. I'm excited for this because the brain is so huge and there's so many connections that, we can talk about this, one bite at a time.
Right. Yeah, I know. I think when we were planning these episodes, because we were like, okay, let's talk about the brain. There's a lot to talk about the brain. But then we were kind of going through it oh, there's a lot to talk about in the brain. So we were like, okay, it's probably better not to try to get it all in one episode. So what we're going to be doing is kind of breaking down the different parts of the brain with different functions, right? With different, aspects and what the different brain areas that are involved in those aspects. And we're going to throw in it's not just going to be all about the brain for the next few weeks. We're also going to be kind of linking some really important, I think, some physics topics in a few weeks that are going to be really, really important connections to some very vital functions of the brain. Hint, keep on the lookout for eyes and light and that sort of thing. But that's all down the line. Today, maybe you clicked on the video, so you already know what we're talking about today. So we are talking about vital functions of the brain, the vital functions that the brain is responsible for. Because I feel like we always get caught up, especially on the MCAT, especially when we're prepping for the MCAT asks a lot about the higher order functions, emotion, movement, these sorts of things. But it's so important when we start talking about the brain to start about the most fundamental, the most critical aspect of the brain, which is the hindbrain, the brainstem, the most important part, which involves our vital functions.
Yes. Mm-hmm. And I love this topic in this episode because guess what we can do when we're talking about the vital functions of the brain? Not only can we build from our previous understanding, right, which we really ended up with gastrulation in our last episode, but we have an evolutionary biology tie-in.
I knew we were going to say something about evolution. I was bracing myself. I was oh.
I feel like you said, so much of what we focus on with the brain and brain function on the MCAT is, like you said, the higher order functions, the things that make humans unique. But really what is interesting to trace is how the brain has changed over time, and how we've all evolved from a common ancestor and how our ancestors have become more and more different throughout, many, many millennia and generations. But ultimately, the oldest parts of the brain are the most conserved, and those highly conserved brain regions are typically the most basic survival-oriented parts of the brain, right? So it's super interesting, right? It's not like the brain developed or evolved from the top down or really just the bottom up, right? It's the brain is kind of developing, yes, top up, but also from the inside out. It's
outwards,
yeah, from the most basic, oldest structures being the brainstem and related structures, and then building itself outwards with all of these very unique, human associated characteristics and higher functions, planning for the future and learning how to use tools and language and personality and all of these things. So super, super interesting, right? The parts of the brain that we're talking about now are actually very, very consistent and conserved throughout the entirety of the animal kingdom. Because pretty much everybody needs to breathe and circulate blood and maintain blood pressure and, have reflexes, etc. So pretty awesome. I'm very excited for today.
I know. As soon as you start talking about evolutionary biology, I don't know if anyone listening isn't going to see this, but you were oh my goodness, this is the most amazing thing ever. Yes, I get to do this. But let's start at where the brain begins, right? And that's when we're kind of really, really picking up from last episode where we talked about the 3 layers, right? But kind of a little bit of recap. We talked about how when sperm meets egg or meets secondary oocyte, right? They'll meet. Oocyte will finish its job, right, and become an ovum, and then they'll meet, they'll form a zygote, and we start those cleavages. We start those rapid cleavages to form, the blastula, all those things and those steps. And if you're interested, if you hear what I'm talking about and you're what are you talking about, Mike? go watch the last episode and you can come back here. But now we were left with three kind of germ layers, right? There's the mesoderm, ectoderm, and endoderm. And we talked about last episode what the fates of these three things are. Endoderm is all the inner lining. Mesoderm was like everything, like kind of most of the organs, like outside of the endoderm. And ectoderm, one of the big things was skin and the nervous system. And now that's the one where it's like, if you follow like endoderm, mesoderm, ectoderm, you're like, oh yeah, ectoderm skin, right? But it's a very important, a very testable part of the MCAT that's both the outside layers, but also the nervous system. And when we talk about how the ectoderm actually ended up forming, the nervous system, this is where we talk about the neural tube. Now, the MCAT does not, if you've ever taken an embryology class, there is so much about, I'm doing this criminal, how briefly I'm going to talk about this. But all that will happen is the ectoderm is like a layer. It will simply form in and form a tube. That tube is the neural tube. And that neural tube is what will become your entire central peripheral nervous system. That's it, right? Where one end of the neural tube will become the brain, the rest of the neural tube will become your spinal cord, and then everything else peripheral nervous system wise. And so, but yeah, it's one end. It's kind of, if you think about like the brain and spinal cord, all of that came from the neural tube. And that's kind of all you need to know, at least MCAT wise, about ectoderm to neural tube. I mean, I don't think I missed anything there, did I, Molly?
Other than the literal name for the process, which I don't think you said,
I
which
don't
is
think I don't think I said that. That's why I was like, I feel like I'm missing something. This is way too short, but neurulation, yes, absolutely.
yes. Yeah.
Mhm.
And so from there, right? Okay, we formed a little tube, and then for the MCAT purposes, we pretty much just like snap our fingers and now we're an adult. Like, that's not how that works. But really, like the majority of the MCAT scope when it comes to brain anatomy, it's all with the adult brain.
Mhm.
That said, maybe slightly lower yield, but still valuable is to think of how this brain actually begins to develop, like in fetal development, right?
Mhm.
And so we go from a neural tube, and then that neural tube is going to mature through various processes that are not necessary to know into three primary vesicles. Now, these are probably terms that you've heard at some point. Okay, we've got the prosencephalon, we've got the mesencephalon, and we've got the rhombencephalon. Okay, so maybe you've heard these terms before, maybe not, right? That well, actually, really, the cephalo is head, right, and
Mhm.
brain. So these are all different parts of the brain. Pros is the forebrain, okay? Mes is the midbrain, and then the rhombencephalon is the hindbrain. Okay, so these are all the most basic early parts of the brain. Do you need to know when these develop? No. What's most important is what these areas develop into, especially because actually they will continue to develop into the structures we know and appreciate about the adult brain. So if we
Mhm.
follow that through with the prosencephalon, right, which creates the forebrain, that is going to further develop into the
Mhm.
telencephalon and the diencephalon, which are going to give us really the majority of those higher order thinking regions of the brain. So the cortex, the parts that control consciousness and thinking in the telencephalon, right? And then the diencephalon, which is a lot of like routing to different parts of the brain and basic homeostasis with the thalamus and the hypothalamus. Which again, you can kind of think they're grouped spatially, like where they end up in the adult brain. Thalamus and
Mhm.
hypothalamus are right next to each other. Cortex is associated with the areas with consciousness, thinking, etc. Mesencephalon luckily stays mesencephalon, right? It becomes the midbrain, but no extra terms there. And the rhombencephalon, there are words, there are names for what it becomes, but really what's most important is, again, as it's the hindbrain, it's the pons, the cerebellum, and the medulla, right? So all of the older regions on an evolutionary basis of the brain, more towards the
Mhm.
bottom, right?
Yeah.
If you were
Mhm.
thinking of a brain diagram.
Right, right. I always like kind of remember when I think about like the proencephalon, mesencephalon, rhombencephalon, I always think like the prosencephalon, that's all like the very human things. Like things like emotion, thinking, prosencephalon, it does all of that, right? All of the limbic system,
Like
most of
prose, actually.
yeah, it's like
Prose
prose,
is like poetry.
yeah. So again, for any of my poetry level lovers, you're gonna love that one. For any of my non-poetry lovers, you're like, what did she just mean?
Yeah.
But like all the prose comes from the prosencephalon. I always think about like, oh, you're a pro because you're
Yeah, or a
so cool
pro. Yeah, yeah,
because you're a human. I mean, but hey, however you remember it, prosencephalon is very much those higher order functions. mesencephalon, midbrain. It's just
Yeah.
midbrain is just a relay center. That's all the MCAT really expects you to know about it. But the
Yeah.
rhombencephalon is like what we were talking about earlier. The survival functions, those core functions, pons, medulla, and for conscious cerebellum as well, which I don't think we're going to talk about too much today. Maybe in another episode, possibly soon. But those ones that are kind of in the back. That's why we call it the hindbrain, right? Because it's in the bottom, in the back, right? So this is kind of just some things that I know because if you're anything like me, like I cannot memorize these for the life of me. So I always need like little tricks like that. I'd be like, okay, what can I associate with these words? And that's why I always kind of find it helpful to do that. But yeah, so today though, we're going to be focusing very much on that rhombencephalon, those rhombencephalonic structures, right? The pons, medulla, not so much on the cerebellum, but on those vital for life functions. Because like Molly, you put it wonderfully, those are the functions that control life. Those core functions. And as you go up, it's not as survival you need it, but it's those core functions that developed first and were so important. So let's dive into that like survival program that, well, I know you like that, that we're now running now that we have, the rhombencephalon, because now we're an adult, we're a human being. We had these three layers, they developed into these brain structures. Now I have a pons, a medulla, but now what do these things actually do? So the first part is that these are all this kind of structure that's not the cerebellum is known as the brain stem. So the brain stem is I always kind of think of it as like the stem because it kind of attaches to the spine, and it's like, oh, it's kind of the stem of the brain, like a flower. It's like that point that goes in the spine. So it's kind of that bottom part that connects, and it's in the brain stem that is the survival center because it has an extremely important structure in it known as the medulla oblongata. Now, the medulla oblongata is a name you need to be familiar with because when you think medulla oblongata, think everything vital for life is medulla oblongata.
Yeah.
Breathing, you need to breathe, regulate medulla oblongata. Heart rate, you need to heart, you need to pump blood, medulla oblongata. Blood pressure, regulating blood pressure, medulla oblongata. This structure is so important for life. And I always love talking about this because I think it's always very, very vivid imagery. I don't know if anybody listening watches like mixed martial arts or fighting or anything like that. But you can imagine mixed martial arts, there's like anything goes, it's, man v man, like female v female, anything like that. But there is one place on the body that you are not allowed to hit, right? You know what that one place is? Is the back of the head, at the bottom of your head, because for two reasons. One, you could hurt the spine and now you're paralyzed the neck down, but also this is where the vital for life functions are. So if you hit that, you actually have serious risk of potentially really harming, if not killing the person that you are doing the sport with. So for that reason, how vital that structure is, like it's so like I always like stressing it, even though it's a little bit visual, I know, but I just wanted to stress how important it is. And even though it's such a shame that the MCAT doesn't ask that many questions on it, when it does ask questions on it, it's about the medulla oblongata and how important it is.
I thought you were going to say it's really a shame that the MCAT doesn't ask that much about MMA.
It really, like, I know
It
it would be
really
so much
should.
more interesting if they asked about MMA.
Oh my gosh. Yeah, no, and that's so interesting, right? Like a lot of people think, oh, the back of the head, it's just the occipital lobe, right? Yeah, it's just vision. It's why if you hit the back of your head, you see stars. It's like, well, maybe the back of your actual skull, but guess what's right underneath that, right?
Right.
It's a lot, especially the back of the neck. I mean,
Hmm.
really, I feel like the neck is just such a sensitive neck and
Uh-huh.
head are so sensitive for injuries. Please protect
Hmm.
yourselves, you guys, especially when playing sports. But that's really interesting. I'm not as familiar with MMA, and that makes a lot of sense,
Hmm.
right? Medulla oblongata is so critical and it's so conserved if we think about why, how things have developed. And it's really like the bottom moving its way up into the brain in the brainstem, like you said. So then we could think, well, we know the medulla oblongata controls really important functions and sort of bodily internal, I don't want to call them reflexes, but
Hmm.
homeostasis, right?
Sure.
Breathing, heart rate, blood pressure, like you said. How does it do this? Right?
Hmm.
How do we know whether blood pressure should go up or down? Or, how do we know what the internal body environment is like? Right? And it all comes down to receptors, right? So we
Mhm.
have receptors that pick up on things like blood pressure with our baroreceptors, or the internal chemistry of, let's say, our blood with our chemoreceptors, right? The medulla oblongata can take inputs from these receptors and use it to regulate body functions. Again, we're not talking about like, oh, I see my crush and my brain and my cognition is telling me, oh, that's my crush. And so my heart rate goes up. Like, no, no, no. This is keep you alive, keep your heart beating. It's not, it's not as integrated. It's very base
Mhm.
level,
Yeah.
survival.
Survival reflex of like I am losing blood, my blood pressure is dropping, start doing something about it
Yeah.
kind of deal. And
Yes. Keep
I
me
love
alive, please.
be alive, please. So this is I love talking about these receptors because whenever I feel like we get talking about receptors, everyone always think molecule, bind receptor, receptor opens. But I love, specifically the
Yeah.
baroreceptors because baroreceptors are what we call mechanoreceptors because they
Mhm.
actually respond to blood pressure by being stretched. They actually feel like, oh, blood pressure is going up. I am now stretched. They feel that stretch and communicate, hey, we're stretching too much. Relax, buddy. Or, right, they're not stretched very much. And they're like, oh, I'm not getting stretched very much. We need to pump this blood pressure up. I
Yeah.
love the baroreceptors for that reason because they're actually mechanoreceptors. They actually feel the movements. Whereas the chemoreceptors, also very cool, but more like your classic. They will actually detect, for breathing, for example, they'll pick up CO2 and think, oh, hey, like, oh, I have a lot of CO2. Might need to do some breathing here because I'm getting way too much CO2. It's chemoreceptors that's actually going to pick it up. And it's very interesting where you can actually see dysfunctions. Like, say you had rising CO2, but a person did not increase breathing. That's actually a sign that you have a dysfunction in your medulla, right? Because it's normal. Like when you're like not when our body has a buildup of CO2, it will just automatically do these things. We don't have to consciously think, oh, I have CO2 in my body. I should probably breathe more, right? We will just naturally do that. But if our body does not naturally do that, that's a sign of medulla dysfunction.
Yes. Yeah. And again, this is really the highest yield thing in the vital functions sort of segmentation of the brain. Like the medulla is so critical. And if you see your body is not responding to something that should ultimately be keeping itself alive, that's probably where you've got issues, the medulla oblongata. So opioids can mess with medulla function and again mess with regulation of heart rate and blood pressure and breathing rate especially, which can contribute to overdose, right? We talk about, respiratory control, like you said, it's very, very important. And when things go wrong, it affects the body in a very extreme and typically pretty like immediate way. Okay. The other elements of the brainstem are not tested in as much depth. Okay. The medulla is very critical. You really want to understand what it is. And even then, if you get a question and medulla is an option, just ask yourself, is the passage or question asking about something that's keeping me alive? That typically is enough to get the
Hmm.
question right in most cases. But the other major components that we'll talk about today are within the brainstem are the pons and the midbrain. Okay, so pons is still part of that hindbrain that we were talking about, right? Midbrain is obviously that mesencephalon, but with pons, what I mostly want you to think of is arousal, right, with the RAS pathway, RAS, reticular activating system, not RAAS, um, right, not the renin, angiotensin, aldosterone system, right? The reticular activating system, which we'll talk about actually a little bit later as well, is all part of sleep-wake cycles and arousal, especially, right? Like if I was going to give you one word I wanted you to associate with reticular activating system, RAS, it's arousal, right? It's
Hmm.
like keeping us awake, keeping us conscious, keeping us alert, right? So Pons is very involved with that. Also, some regulation of breathing, but not like keep you alive breathing. It's more fine tuning, right? Putting the last little regulatory, salt on top for
Yeah,
the
I can just
medulla
imagine the
oblongata.
pawn sprinkling regulatory salt on your brain.
Like right after the meal's already made, right? Just the
It's just
little
like
final
finishing things off. But yeah,
finishing
you're
touches.
100%.
Yeah.
It's just like helping things out. And this is, I think, one thing that's really important when discussing the brain. We were talking about this before, Molly, where the brain is so complex. I think this is so important to
Yeah.
preface when we're going to be, because we're going to be talking about the brain in so many future episodes, that we're going to be focusing mostly on like the unique functions of these brain areas. But when we talk about these brain areas, there's so many brain areas that do multiple things that overlap with each other. Like, oh yeah,
Yeah.
medulla does breathing, but also pons does breathing, but there's also other parts that do breathing. But like if
Yeah.
we're gonna always gonna be focusing on like the MCAT testable stuff. It's like what
Yeah.
will the MCAT expect for you? If you want to go on and be a neurosurgeon and go off
Please do.
and come back and let us know. But for
Yeah.
for us here, we're gonna just focus on the main functions. Like you said, pons huge for sleep wake cycles. Absolutely, absolutely. But then also it does a little bit of sprinkling with the breathing fine tune. Love that.
Yes. Yeah, it's like, okay, if I see this word or
Hmm.
phrase, what is my first thought when it comes
Right.
to the brain? Right?
Hmm.
Same thing with neurotransmitters, which we've talked about in previous episodes. Like if you hear acetylcholine,
Hmm.
your first thought is probably muscle contraction. Because
Yeah.
that's like the most important. Acetylcholine is actually really important with attention. It's important with sympathetic and parasympathetic signaling, etc. But like the first thing you should think of is probably movement, right? Or if they're talking about movement and neurotransmitters, acetylcholine should be the first thing, right? Like there may be other things out there that might contribute to some of these other functions, but like when I hear this, what should I be thinking of, right? If you hear breathing issues, medulla oblongata, technically pons too, but that's not the first thing that should pop in your head, right?
Exactly. Exactly.
Yeah,
Exactly.
that's kind of the mindset you want to have to make sure you don't miss anything. It's the whole idea of Occam's razor of like, if you hear hoofbeats in the forest, you think a horse, not a zebra, right?
I love Occam's razor, like just to keep things simple. Because
Yeah,
I think a lot of students listening actually feel like they overthink too much. They're like, oh,
yeah,
they could be doing this, they could be doing this. And that's why stressing on like those buzzwords. And when we talk about like science strategy, like hooking on the you see breathing issues, buzzwords should activate, oh, medulla issue, not pons
Mhm.
kind of deal. But
Yeah,
again, that's why we love prefacing, okay, what should this help you think in order to help you increase your score on the MCAT, which is what we all want to, and also that you learn something cool, which is nice.
yeah,
I guess the last the fun structure in our brainstem, because we've talked about the medulla a little bit at length at this point. If you don't realize how important the medulla is, go rewind about like 10 minutes and we'll talk. But pons also important, more for like sleep weight regulation. Then there's the midbrain, which is kind of like the highest of the, like if you're like to go up, it's kind of like above the pons a little bit. And that's more for like reflex signals, like reflexing specifically with visual and auditory signals. And it also is involved in like motor reflex relaying. But when you think midbrain, I always kind of think about relaying reflexes. We know about our reflexes, like, touch a hot stove and move your hand kind of reflexes. You see something coming at you and you move instinctively reflexes. That's the visual reflex. You hear something loud in your ear, you move away from it right away, right? All those reflexes are relayed by the midbrain. So when you think midbrain, that's what you should be thinking about. So that's a really, again, in terms of brainstem structures, pons midbrain, not that much because they have really critical functions. Medulla oblongata, that's the real big one.
yes.
Hmm.
So we've made our way through the major components of the brainstem already, and those are really the ones that control our vital functions. There are other very critical parts of the brain, of course, but like when it comes to keeping you alive, those are the most important ones, right?
Hmm.
There are lots of things that we could talk about that relate to these functions or to these structures. And we'll get into a couple. I think the most important is RAS. And again,
Hmm.
RAS, reticular activating system. We mentioned it a little bit with pons, right? But it's this whole idea of maintaining alertness. And I want to bring this back up because we were talking about this earlier. There's a lot that can happen if you damage structures that are part of this reticular activating system or RAS, right? Specifically, if you damage these structures that are designed to promote alertness, you could go into a coma, for
Hmm.
instance, or you could go unconscious, right? If you're completely unconscious, really for no noticeable reason, right? It might be due to damage in the structure or the structures associated with RAS. And this is also how anesthesia works, right? It suppresses RAS activity, so it suppresses your alertness. But I think our communal favorite as perpetual caffeine addicts, is caffeine. I
We
know
love
we're
it.
like cheersing our mugs of coffee. Caffeine, which is really, if we talk about psychoactive drugs and materials, it's the most widely used psychoactive substance, right? What it actually does on a biochemical level is it's going to bind to and inactivate receptors for adenosine, which
Mm,
is a molecule which is going to ultimately inhibit the RAS pathway. Um, Super cool. You could dive in to a whole rabbit hole with this. It's actually really fascinating. It
mhm,
accumulates throughout the day because it's actually a byproduct of ATP. So
mhm,
it's something that accumulates as you've been awake for a long time, and it's meant to inhibit the thing that keeps you alert so you go to sleep. And during
mhm,
sleep, you clear it, you wake up, you feel refreshed, lower adenosine, high alertness. The thing about caffeine is it's going to bind to adenosine receptors and prevent them from inhibiting RAS.
mhm.
So it's not directly caffeine stimulates alertness. It's that caffeine prevents you from turning off your alertness.
Yeah.
It's an interesting system, which is why, caffeine, when you're already really, really, really exhausted, doesn't really hit the same as
Yeah.
caffeine straight in the morning.
Straight in the morning, right after you wake up. And I think
Yeah.
it's so, so cool because, yeah, a lot of us, we know when we get tired, we know we're awake. It's really cool to think about. Yeah, it's because of a buildup of adenosine, that molecule that's so important. It's related to ATP. Of course, the brain is very metabolically active. So, of course, right, when you're thinking a lot, when you're going about your day,
Yeah.
you're going to produce a lot of this waste product. So, it's no wonder then that's the one that actually, turns off your ass to say, hey, go to bed, go to
Sleep
sleep.
time.
Sleep time. And then if they've done so many cool studies on like the draining of the brain, like when you're asleep, and it's actually one of the leading theories as to why we sleep. Because again, I know sleep is very like a contentious topic, because they're like sleep, that doesn't sound. Why would our early ancestors I know you love this, Molly, about evolution. We're like, why would our early ancestors want to be asleep for a third day? That sounds dangerous. But one of the leading theories is because of this impact on adenosine to clear it out of the brain. I know,
Yes.
I know. I was like, you're gonna love this one. I know that. But, but it's also why caffeine affects, the adenosine receptors that affect the RAS, but it doesn't wake up other parts of the brain. And this is one thing that's really, really important about performance, when you're tired, when you drink caffeine. Because while it's impacting your RAS to kind of keep you from going to bed, it's not activating the other parts of your brain. So other parts of your brain could actually still be asleep. It's filled with adenosine. So it's why like people are like, oh my goodness, I'll just pull an all-nighter, I'll take caffeine. It's like, no, actually, while your RAS is not causing you to go to bed, like your frontal lobe, your decision making is not as active at this point, even though you're drinking caffeine. So it's like, yeah, your parts of your brain are actually still asleep, even though you're awake when you're forcing yourself to drink caffeine. And I think that's such a cool idea. And why get some sleep, everybody. You're listening to get some sleep. My goodness, stop drinking caffeine all the time. Get some sleep. Give your brain a chance to actually rest and wake up and actually do some studying. Sorry, I feel very strongly about this.
Be like us, drink a bunch of caffeine and then go to sleep,
And then
and
go to
then wake up
sleep.
and drink more caffeine.
Absolutely. Don't do as we say, not as we say.
Yeah, I know, for real. I love that, right? And again, there are many other benefits of sleep for your physical development and regulation, but also for things like memory. This is not the only thing to clear it from adenosine or clear the adenosine out, but it's really important. And I love that you bring that up because too often we're like, I just want to get through one more, section of my full length that I want to review, or like one more chapter of this textbook or whatever. Like I'll just pound some coffee, call it a day. It's like sometimes, when you're already exhausted, putting in an extra 2 hours when most of your brain is dulled is not beneficial. It would be higher yield for you to go to sleep for those 2 hours and wake up and you're twice as productive in the morning, right? Be smart about it. Okay.
Hmm.
A lot of us define our, you know, like quality as a student or
Hmm.
our identity as a student as like how many hours I put in. This is your, PSA. Be selfish with your time and also learn brain science first and then
Learn brain science.
use that to decide how you want to study because too often we're just like, I'm just gonna bull right through. I don't care if I'm tired. And you know what? So many of us waste time and make ourselves miserable with that. You know, the whole idea of like study smarter, not harder, it's such a cliche, but it's also super important. So
Super true. Right.
think about that next time you start an all-nighter, right?
And that's why I think we even talked about this a lot with like psych social when we first talked about psych social like so many episodes ago. It's like
Memory, especially.
we when we were talking about like psych social, we were talking about like how yes, we have to or get to study this on the MCAT, but also not only do we have to learn it for the MCAT, we can also use these tools that we're learning to actually better our studying. So if you listen to the memory and encoding episode, you know what we're talking about. If you haven't, go check it out. We talked not only talked about what you need to know for the MCAT, but also how you can use what you learned for the MCAT to better study for the MCAT. So go check that out if you haven't. It was really good, but this is just another example of that in Psych Soc. Um,
Yes.
and speaking of like vital for life functions, like these vital for life functions, I think it goes without saying, you don't have to consciously think about vital for life functions. Like I am not constantly saying heartbeat, go, bang, heartbeat, go, bang. I'm not constantly, that would be awful if I had to do that, right? And this is kind of like leads us to anyone listening is like, oh, I know where he's going with this. Leads us to a really important branch of the nervous system that's important to talk about when talking about vital functions, which is the autonomic nervous system. Now, the autonomic nervous system, I always think about it as the automatic nervous system. As compared to the somatic nervous system, which is all about conscious movement. But the autonomic nervous system is all about anything you don't have to consciously control. So, big picture, it controls things like it is how the medulla actually controls heart rate, blood pressure, and other things like digestion and pupil dilation, right? You don't have to think about it, but it's how things like the medulla actually cause the change. They cause it because it's in the brain and they cause signals to actually lead to those changes. Now, when we talk about the autonomic nervous system, I'm sure everyone's heard about the two branches of the autonomic nervous system, the sympathetic and the parasympathetic nervous system. And the sympathetic, that's the fight or flight response. Everyone's heard the fight or flight response, but that is truly like the stress, exercise, emergency. You're either fighting the bear or running away from the bear because this is really, really stressful. So this is when your heart rate goes up, blood pressure goes up, right? These are the things where, again, you're not consciously thinking about it, but these are where it's regulated, right? Your heart rate and blood pressure, like we talked about before, go up. A lot of the times, these specific sympathetic and parasympathetic aren't actually initially caused by, the medulla oblongata, because a lot of these could be like, oh, I have a crush. Now, oh, I'm getting stressed. So, like, that's not a vital for life situation, but more so, I am bleeding out. Oh, this is bad. I need to do something about this kind of deal versus the parasympathetic response, which is your rest and digest response. And this is when, yes, heart rate is going down, your digestion is going up, blood to the gut, and that means we need to rest a little bit. So in this way, right, I wanted to touch on it briefly in order to recognize that these vital for life functions are kind of carried out through autonomic factors, not through somatic. You don't have to consciously do these things.
Yes, absolutely. And by the way, you guys, there are so many diagrams out there that will show every one of the individual sort of in air quotes here symptoms of having an active sympathetic nervous system or parasympathetic nervous system. And with those, please don't memorize them. They make
Please.
sense, right? Like, okay, pupils are involved. It's like pupils dilate when we talk about sympathetic. Why? It's like pupil just allows light into the eye. If you dilate them, more light into the eye, you are more aware of your surroundings, right? If you're resting and digesting, you don't need that, right? Go through a diagram like that. We've actually touched on sympathetic and parasympathetic in a couple episodes in the past, but make sure you're comfortable with this. I would say this is pretty high yield as well. But yeah, and it's kind of interesting, right? Fight or flight, rest and digest. We think those are vital functions, and they are. They're very important for regulating vital functions. But like you said, sometimes our higher level, more human specific functions can use those same pathways to activate the body or activate these different elements of the nervous system, even in situations that aren't truly, life or death, which is honestly just cool. We're
Right.
going to talk a lot about the higher level functions of the brain later, how we have things like crushes and what's going on with that. But coming back to
Little
crushes.
crushes there. But why it
Yeah,
also
little
feels
crushes.
like when you have a crush, it's like, oh my goodness, the biggest deal in the world, right?
It's fight or flight. Like, oh my
Right.
gosh, my crush is looking at me. It's like
Right, like
I'm,
this is the worst, right? It's not just
yeah,
your body is actually reacting to it in the way as if you were in danger. It's the coolest thing. That's why, yeah, we're super excited to talk about it later.
I love it. Yeah,
Yeah.
and I mean, of course, in this first episode in our brain exploration here, we're really focused on just the vital functions, but we've also kind of built our way up from gastrulation, right? From
Hmm.
that ectoderm into the structures that we see in an adult human,
Hmm.
which is super, super interesting, right? And from there are so many different avenues we could go into with the different brain areas, but also how the brain is regulating all of the rest of the body, essentially. So we get to kind of talk about the brain, which is psych, soc, and biochem depending, right? But then also how it relates to all body systems and even how, physics and chemistry can play a role here. It's going to be kind of fun. So, what are we going to talk about next week?
I'm so happy you asked, Molly. So next week we are talking about the motor control of the brain. Like we are moving our mouths, moving our hands. Well, what decided that? It's all about the brain. So next episode we're going to break down, okay, what parts of the brain are involved in motor control? What is the order? Because I remember when I first studied motor control of the brain, I was like, oh my goodness, there's so many things involved in motor control. The cerebellum's there, but then there's the motor cortex, but also there's the like dopamine's
Ganglia.
evolved somehow, and I know the basal ganglia is there, and I'm like,
Yeah.
oh my goodness, all of this is motor. Like, why can't this be simple? Well, obviously the brain can't be simple, but we'll do our best to make it simple next episode. So stay tuned. I hope you all enjoyed this episode on vital functions. We hope you all have a wonderful wherever we're finding you in the day, night, on a train. But until then, happy studying, everybody.
Bye, guys.